Hello, this is Ann Bear. I wanted to create a video for you today on section 12.3, Extended Power Rule. This rule is not on the Survey of Calculus formula sheet, so please be sure you know this rule for Test 2 and the Comprehensive Final. When do we use this rule? We use this rule when we're given a function, f of x, in the form a base to a power. And the base is something other than just x. And we're asked to find the derivative of the original function, or need to find that derivative. There are 4 steps. The first step is we bring the power down in front and write it down. Then we copy over the base. Then we find the new power by taking the old power and subtracting 1. And lastly, we then multiply by the derivative of the base. This prime means to find the derivative. If this sounds familiar, it is. Back earlier in the course, you were asked to find the derivative of, say, x cubed, or x to the 5th, or x to the negative 6th. Those are in this form a base to a power, but the base is just x. You use 3 parts of this process to find the derivative of, say, x cubed. You bring down the power 3, you copy down your x, and to get the new power, you take 3 minus 1 to get 2. So the first 3 steps are exactly the same. In the case of a base to a power, where the base is something other than just x, we have an additional step of multiplying by the derivative of the base. Let's take a look at a couple of examples. So first, let's take a look at problem number 1 in the homework. This is the exact number 1 I have in my class notes. We're given that our function y is equal to 5x to the 4th minus 8x squared plus 6, all raised to a power of 4. So we have 4 steps. We have 4 steps because this base right here, encircled in blue, is something other than just x. So what are our 4 steps? The first 3 are the same as in the simple power rule. You take the 4, you drop it down front. So I copied this 4 down. You then copy over the base. In the past it was just x we copied over, but now we copy over the base, the entire base. 5x to the 4th minus 8x squared plus 6 just gets copied over right here. And then to get the new power, we take the old power of the old power of 4 and subtract 1. And then lastly, our new step. What does the new step say? It says to multiply by the derivative of the base. So here's our base. We differentiate term by term. Let's start with this first term here. Terms are added. Start with the first term. So we take the 4, bring it down, multiply it times 5 to get 20. And then we have to multiply that by x to the what power? We have to decrease the power by 1, third. So we get third. So we get x to the 3rd here. Moving along, the next term. Minus sign, copy that down. 2 times 8 is 16. Times what? X to the 2 minus 1. That's x to the 1st. And we can just write that as x. So we just want to clean this up a little bit if we can. Just doing arithmetic, and looks like all we can do. This is the same. This gets copied. 4 minus 1 is 3. And this gets copied down. So in MyLab Math, we can take the derivative and stop. You could, if you got this exact problem that I did, you could take the derivative, get this, and then enter it in MyLab Math. If you entered it correctly, MyMathLab would count it right. You can take the derivative and stop in MyLab Math. I do want to caution you though, if you enter this and you get it slightly wrong, MyLab Math is going to give you something that has the correct answer that doesn't look like this. Possibly, it may not. In some of the problems, it's hard to tell. So the risk of taking your derivative and stopping in this, like say here, if you made an error in data entry, you may not know where you went wrong in MyLab Math. So I just want you to remember that. And that's true for any derivative problems. If you're asked to find the derivative, you can take the derivative and stop. If you use the quotient rule, the product rule, the extended power rule, whatever, or you use any of the other rules we're going to talk about throughout the course, you can take the derivative and stop. I do encourage you to do the arithmetic, but MyMathLab is only going to give you one correct answer that they've decided on. It's not going to necessarily give you the correct answer for where you stopped and entered it. That's the best I can put that. So that's the drawback. Let's go ahead and look at another problem. This is the last one that I'm going to do. I'm going to do problem number 6 in your homework, and this is the exact problem 6 I have in my class notes. So we have y equals this function. You will notice that we've got this factor right here times this factor right here. There's an understood multiplication symbol in between. So I can view this side of the function has a product. And later on in this problem, we're going to use the product rule. So in order to use the product rule, we need to have a u and a v. And the product rule is on the formula sheet. So you want to select your u and your v so there's an understood multiplications symbol between them. So in this case, u is here in green, v is here in purple. Now, since we know we're going to use the product rule, and the product rule has u prime and v prime in it, we need to find the derivative of u and also the derivative of v. So let's start by finding the derivative of u. U is a base to a power, where the base is something other than x. So we definitely want to use the extended power rule here. So u prime, I'm going to bring this power down in front. So we're going to copy down the 4, write this down, this base as is, 5x plus 1. To get the new power, it's the old power 4 minus 1, which is 3. And then we need to multiply by the derivative of the base. This base is in mx plus b form, so the derivative is the slope, which is 5. Let's just clean this u prime up a bit by taking the 4 and multiplying it times 5 to get 20. And then copying down 5x plus 1 cubed. Now let's find v prime. V is in purple. And we have a base to a power where the base here is something other than x. The base is sitting beneath the exponent. Our base is 2x plus 3. So let's take the derivative of v. Let's bring that negative 3, this negative 3 here, down in front. Copy it over here. Copy over the base, 2x plus 3. Take the old power, minus 3, and subtract 1. So get negative 3 minus 1 here. And then multiply by the derivative of the base. That base is in mx plus b form. The derivative is the slope, so the derivative is 2. Cleaning this up, negative 3 times 2 is negative 6. Copying over 2x plus 3. Negative 3 minus 1 is negative 4. So now we're going to use the product rule. So I copied the product rule off the formula sheet. And so let's plug in what we need to where. U of x. U of x is 5x plus 1 raised to the 4th. So that goes in right here. V prime of x. And of course, that's times v prime of x. V prime, negative 6 times 2x plus 3 to the negative 4th. All got copied down here. Then plus, that plus goes right here. Let me get this up a little higher. That plus goes right here. Okay? And then we need this v of x right here. So v of x is going all the way to the top up here, 2x plus 3 to the negative 3. So that goes 2x plus 3 to the negative 3 goes to the right of that plus sign there. And lastly, we need to go get u prime of x. U prime, 20 times 5x plus 4 cubed. Actually, it's 20. Let me take a look. U prime is 20 times 5x plus 1 cubed. So 20 times 5x plus 1 cubed. I think I might have misspoke there. But anyway, it got copied over right here. So we've taken the derivative, and now we can stop. We can enter what I've encircled in black in MyLab Math. Now, certainly for something like this, if you entered it in MyLab Math wrong, I can guarantee you that the answer MyLab Math is going to give you is not really going to look like what you entered. So please be very careful. Even though if you entered this correctly, MyLab Math will take it if it's entered correctly. If you enter it wrong, you're not going to likely recognize the answer and be able to tell what you did wrong. So that's all I have for you right now. Please, if you have any more questions on the extended power rule, do not hesitate to email me. So that's all for now, and I am going to end this video now.